right, sorry about that. My kiddos needed some attention. So in these ones that have a leading coefficient other than 1, I'm going to use the box method. And again, this is just one of the options. It's my preference, doesn't mean it has to be yours. Okay? So when I do the box method, okay, I draw that box and I split it in half both ways. My first term goes in the first box, and my last term goes in the last box. And I again need to think about my signs, okay? And so when I look at this one, I have that third term that's positive again, but that middle term that's negative again, which tells me both of my problems are again going to be subtraction, okay? Because that negative times a negative gives me a positive, and adding those two negatives still gives me a negative. Okay, so the first thing I look at is my first term. And I know the only factors of 2, so this one's pretty nice, are 2g and g. Okay, awesome. Okay, now the next one I look at is my last term. Okay, 17. Okay, but what I'm looking at for this one is I know I'm going to need factors of 17, okay, but I have to think about what they give me to get that middle term. Okay, so this one, the only factors of 17 are 1 and 17. So if I think about putting a 1 right here, I'm going to take 2 times 1, and I would get a 2g, a negative 2g. Okay, that would mean my 17 is here, and when I take 1g times 17, I get a negative 17g. And if I were to combine those two, I would get a negative 19g, which doesn't work. Okay, so can't be that way. Okay, so let's try it the other way. If I put that 17 here, when I take 2 times a negative 17, I get a negative 34g. Okay, my other factor was a 1, so when I put that 1 there, 1g times a negative 1 is a negative g. Okay, so when I check these two, because these are the two I'm combining, negative g minus 34g gives me that negative 35, oops, forgot the g up there, g that I had for my middle term. So that checks. So my factors for this one are right up here along the top, okay? This g minus 17 times the 2g minus 1, okay? And if I can again now check my answer the same way I did before using that FOIL. So I get 2g squared, okay, minus g minus 34g plus 17, because a negative times a negative is a positive. And again, when I combine those two, I get a negative 35g, so it checks. Okay, so let's try another one of those, but this time when that leading coefficient isn't a prime number. So now I'm going to have to think more about my factors again. Okay, so I know I'm going to use that box method because I have a leading coefficient of 10. Okay, and so that 10v squared goes here, and my last term of negative 8 goes down there. Now again, my last term is negative 8, so I know I'm going to have a positive and a negative. My signs are going to be different because my last term's negative. Okay, so I know that one of these has to be plus and one of them has to be minus. Now the trick is, this time I can't put them in because I have to figure out which one's going to be positive and which one's going to be negative. Okay, so when I think about this one, the factors of 10 are 1 and 10 or 2 and 5. Okay, usually you always just remember this is just trial and error. Okay, but usually you want to pick the one that's not 1 and something. Okay, so I'm going to pick the 5v and the 2v. Okay, because 5v times 2v gives me 10v squared. And now I have to think about my factors of 8. My factors of 8 are 1 and 8 or 2 and 4. Okay, if I use 2 and 4, 2 times, if I put 2 here, would give me a 10v. And if I put a 4 here, 2 times 4 gives me an 8v. And again, these are going to be different, so I'm going to need to subtract. if I take 10 minus 8, I only end up with 2. Okay, so that doesn't work. Right? So 2 and 4 aren't my best choices. Okay, but if I switch them around, because that would change my numbers, if I put a 4 here and a 2 here, 5 times 4 gives me a 20V, and 2 times 2 give me a 4V. And when I take that 20V minus 4V, I get 16, which is still not what I wanted. Okay, so the other factors of 8 are that 1 and that 8. Okay, so I put in this one. Okay, if I put a 1 right here and an 8 here. Okay, 5V times 1 is a 5V. Okay, and 2 times 8 is a 16V. Again, we're going to subtract these because they're going to be different signs. So if I take 16 minus 5, I do get that 11. So I know that this one right here is going to be a 1, and this one right here is going to be an 8. Okay, now the trick is which one needs to be positive and which one needs to be negative. Since my 11 is positive, my bigger number has to be positive. So this one that gave me that 16V has to be positive, while the other one is negative. So leave myself much room here, but the factors then should be 2V minus 1, okay, and 5V plus 8. Okay, and if I check that with that FOIL, 2V times 5V gives me 10V squared. Outsides, 2V times 8 is a positive 16V. Insides, minus 5V. And last, negative 1 times 8 is a negative 8. That's what I wanted. And when I check this middle, again, 16 minus 5 gives me that positive 11. So it checks. All right. So those are those leading coefficient ones. Okay. But sometimes those leading coefficient ones can even be a little bit trickier. Okay. First, whenever you notice your leading coefficient is negative, you should know you have to factor out a negative 1. Okay, so I know for this problem I'm going to have to factor out a negative. Sorry, my dog's shaking my computer here. See? There she is. Scratching her ear. Okay? But when I factor this one, I should also look at these numbers then. And I notice that those are all even numbers, so I'm going to have to divide them all by a 2. So I can factor out in this one right away. Sydney, go away. Right? I can factor out right away in this one a negative 2. Okay? And when I do that, okay, I get negative 2 times the quantity of, right here, negative 2 divided by negative 2 just leaves me with h squared. When I factor out a negative 2 to this middle, 4 divided by negative 2 is a negative 2h. And I factor a negative 2 out of 70. 70 divided by negative 2 is a negative 35. Okay, so now on this one, even though it started with that leading coefficient of negative 2, once I factor that out, I end up with one of those nice ones that has a leading coefficient of 1. So now I can just use that x method. And I know I need to multiply to get a negative 35 and add to get a negative 2. Okay? Again, since this third term is negative, that should right away tell you we need one term that's positive and one term that's negative. Sorry. Okay? So on this one, then what I look at is that middle term. Okay, that middle term is negative, so my bigger number has to be a negative. Okay, so when I think about 35, the factors of 35 are 5 and 7. Okay, so when I use 5 and 7, the bigger one is 7, and the smaller one is 5. And if I check that, 5 times negative 7 is negative 35, but 5 plus negative 7 is a negative 2. Okay, so those factors there are going to be h plus 5 times h minus 7. Okay, and if I check that, I have h squared plus, outside, so minus 7h plus 5h minus 35, getting me that negative 2h here. Okay, but if I remember in my original problem, that middle term wasn't -2. That was here. My original problem was 4. So whenever you do that checking, make sure it doesn't match your original. You check that you didn't miss something that you factored out already. I also have a factor of -2. So that goes out in front. Okay. All right. So here's another one. Okay. Now this one again is a trinomial, but it doesn't have a leading coefficient. Okay. And the reason I put this one in here is just to remind you, whenever you have those, okay, whether you have a leading coefficient or not, look if you have a perfect square. Okay. When I have S, this is an S. It kind of looks like a 5, but it's an S. Okay. S squared is always a square. Okay, so a square root is S. In here, I have 100, whereas in any of these other problems, my last term wasn't a perfect square. But this one's a perfect square of 10. Okay, so I have S squared and 10 squared. Now, if I notice I have those, okay, I should look at my middle term. Remember, the rule for this is 2AB. Okay, so is that middle term 2 times S times 10? Well, 2 times 10 is 20S. So it checks. So for this one, okay, I could have made the X method, but since I realized these were perfect squares, I should right away know that this is a perfect square trinomial, which means I'm going to have a quantity squared. Okay, and in this case, S squared, the square root of that is S. 100, the square root of that is 10. And since that middle term is negative, that means this is a subtraction problem. Okay? All right, so make sure you always look for those squares, even if you have a leading coefficient. Okay, so let's look at another one of those quick. I don't think I have one written down, but let's do one where we have a 9. Can't see what I'm doing here. A 9x squared and 64. Okay, and we'll make them all be positive. Okay, so let's make it be this one. Okay, so if I look at this one, I could go ahead and make that box, but if I look at this and I notice that 9 is a perfect square, which means this is really 3x squared, because 3x times 3x is 9x squared. And if I look at the 64, I know that 8 times 8 is 64, so this is really 8 squared. Okay, now make sure when you notice that you still always check your middle term, that 2AB. So I should have 2 times 3x times 8 should give me 48. Well, 2 times 3 is 6. So I have 6x times 8, and 6 times 8 is 48x. So it checks. So on this one, okay, it's still going to be a perfect square trinomial, so I have that quantity squared, but now I have a 3x and an 8, and since this middle term is positive, this is an addition one. Okay, so make sure that you always look for those two. Okay, so what happens if you only have 2 terms? Okay, if you only have 2 terms, first check, does anything factor out? Well, r squared, nothing's going to factor out, and this one doesn't have an r, so it doesn't factor. Then check if you have perfect squares again. So this one, I have r squared, and 64, which is the number I did last time, but is 8, okay, squared. So right here, I have a difference of squares. So whenever you have 2 terms that are squares, you end up needing 2 factors. So I should have r minus 8 times r plus 8. So a difference of squares, because when I check that, I get r squared plus 8r minus 8r minus 64. And those middle terms cancel, so I have my difference of squares. All right. So the last type of thing you did was when you had a problem that had more than 3 terms. Okay, so let's look at this one I have right here. Okay, when you have that, first check, okay, does anything factor out of every single number? Okay, well this is even, but this one's odd. Okay, here 3 will come out, but 3 won't come out of 40. So nothing's going to factor out of all of them. So what I do is I separate them into 2 separate parts. Okay, and then I factor each of those parts separately. So when I think about 12 and 27, I know that 3 can go into both of those. Okay, but I also need to look at my variables. Okay, I have k cubed and I have k squared, which means I can take out that k to the lowest of those 2 exponents, which in this case is the 2. Okay, and when I factor that out, 3 times 4 gives me 12, and k squared times k gives me k to the 3rd. Okay, and then 3 times 9 gives me 27, and it's minus because so it's negative. Okay, and k squared is already there. Okay, so I look at the second one. Again, that leading term is negative, so I know I'm going to need to factor out a negative. Okay, and what goes into 40 and 90 is a 10. Okay, and so this time I'm factoring out negative 10. So when I do that, negative 40 divided by negative 10 is 4. And I still have a k because I couldn't factor out a k because there's k here, but not here. Okay, then 90 divided by negative 10 gives me a negative 9. Okay, and when I look at that, what you should notice is that these 2 terms end up being the same. Okay, so what I do is I combine the 2 outside parts. So I have 3k squared minus 10 times that quantity that was the same. And where this really comes from is from that distributive property. Okay, and if I check this over, 3k squared times 4k gives me 12k to the 3rd. 3 times 9 gives me a negative 27k. Sorry, 3 times negative 9. Insides, negative 10 times 4 gives me a negative 40k. And last, negative times a negative gives me a positive 90, which is exactly what I started with. So these are my factors. Okay. Now when you're done with those though, one other thing you should do is make sure that you factored completely, because anytime, even if your directions just say factor, remember that means to factor it everything you can. So factor it completely. Well, nothing goes into 3 and 10, and nothing goes into 4 and 9. So I'm done. So let's look at one of those that's a little bit trickier. Okay, so right here, okay, I have 40 to the 4th plus 40 cubed minus 60 squared, okay, minus 4d. Okay, when I look at this one, I notice that every single one of these terms is positive. And I also notice that every single one of these terms has a d, okay, which means I can factor out a 2d out of every single term, okay? So when I do that, 60 to the 4th, 6 divided by 2 gives me 3. 4 to the, or d to the 4th divided by d gives me d to the 3rd. Okay, the next term, 4 divided by 2 gives me a 2. D to the 3rd divided by d is d to the 2nd. Okay, negative 6 divided by 2 is negative 3. And d squared divided by d is d. Okay, and the last one, negative 4 divided by 2 is a negative 2, and d divided by d just goes away. Okay, so I'm still left with 4 terms, but now I have smaller numbers to work with. Okay, so I'm going to separate these again into 2 different parts. Okay, so if I look here, okay, 2 and 3 aren't divisible by anything, but d cubed and d squared both have a d squared in it. So I'm going to factor out d squared. okay? When I do that, I end up with 3d, because I couldn't take anything out of the number, and d cubed minus squared is just 1, plus 2, because the d squared is already there, okay? When I look at this next one, again, that leading number is negative, so I know I'm going to need to factor out a negative, okay? And when I think about this, when I factor out a negative, okay, there's nothing that goes into 3 and 2 again, and there's only a d in the first one, so the only thing I can factor out is a 1, okay? Which leaves me with a positive 3d plus 2, which if I look at that, okay, is exactly, again, those two parentheses are the same. So what I have is d squared minus 1 times 3d plus 2. And if I check that, d squared times 3d, okay, gives me 3d cubed plus 2d squared minus 3d minus 2. Okay, but again, that's not my original, so I have to go up here and remember that I already factored out a 2d, right? But now when I look at this one, I'm going to double check to see if I can factor it any further. Nothing goes into 3 and 2, so there's nothing I can factor out there because the d is plain. But here, I have a d squared, which is still a perfect square, and a 1 that is still a perfect square. So what I actually have here is a difference of squares, which means I can still factor this again. So I end up with 2d times d minus 1 times d plus 1 times 3d plus 2. Okay, checking to make sure that you factor completely. Okay, most of the time if you already factored out something first, it's not going to factor again at the bottom, but sometimes it will. So make sure that you always check for that. Okay, all right, and that's really your review other than the word problems. Okay, with the word problems, remember if they're talking about area, okay, you have to look at what shape they're giving you. If you have a rectangle, okay, this is for area, we know that that's length times width. So we need two separate dimensions. So we're going to have a quantity times a quantity. Okay. If they're talking about a square, okay, that means we have all those sides. Let's give myself some more paper here. Okay, if we have a square, we have all of those sides are the same, which really means we have one quantity squared. Okay, so you're looking for a difference of squares. Okay, or sorry, you're looking for a perfect square trinomial. Okay, and if they ask you about volume, remember volume is for three-dimensional shapes. Okay. Okay, so we have a length, a width, and a height. So on that one, you're probably going to have one of those that factors something out of everything and gives you those three factors. Okay, good luck on your review. You need to get an 11 out of the 14. Those ones are multiple choice, but please do the work for them because you do have to upload it. And then you have a quiz afterwards, okay? Your quiz isn't going to tell you, sorry, 2-year-old on my lap, okay? Isn't going to tell you what's right or wrong, okay? But you will be able to see your score once we grade it, and you need to make sure you submit your work so that we can give you partial credit. All right, good luck, guys. Miss you.